Tangent sum and difference formulas make no sense. Do you feel as if mathematicians are pulling numbers out of nowhere? Don't worry, because the tangent sum and difference formulas can be easily derived with a bit of algebra. If you haven't seen my previous video where I covered the sine and cosine sum and difference formulas, you should check it out. That way you will have a solid understanding of the foundation of this proof. So before we get started, we first need to prove a property, or a trig identity actually. So let's say we have a right triangle with an angle of theta. Actually, let me redraw that. A right triangle with an angle of theta. And let's say it has a hypotenuse of length r, and the side opposite to theta is going to be called op, and the side adjacent to theta is going to be called adjacent. So we know that sine theta is going to be equal to opposite over hypotenuse, which is just r in this case, and that cosine theta is going to be equal to adjacent over hypotenuse, which is just r in this case as well. And we can just rearrange these equations to get that op equals to r sine theta. And we did this by just multiplying both sides by r. We also know that adjacent is going to be equal to r cosine theta. Now tangent theta, as you recall, is going to be equal to op over adjacent. And we can just plug in the values that we got for op and adjacent into opposite and adjacent over here as well. So we get that tangent of theta is going to be equal to r sine theta over r cosine theta. Now if you notice, the r's here are actually going to cancel out, and I'm just going to erase them. So now we know that the sine of theta, the tangent theta is going to be equal to sine theta over cosine theta. Now this is a very important property that we will be using a lot today. So that's pretty much the basics of this proof, and now we can continue on. Alright, so we know that tangent of theta is going to be equal to sine theta over cosine theta. So if we replace theta with alpha plus beta instead, we will get that tangent of alpha plus beta is going to be equal to sine of alpha plus beta over cosine of alpha plus beta. And again, we know this is true because we can just plug in alpha plus beta into theta over here. So if you remember from the last video, the angle addition formulas for sine and cosine, we can rewrite this as tangent alpha plus beta. It's going to be equal to sine alpha plus beta over, I'm actually going to write all the denominators in a different color, cosine, oh sorry, I meant to expand these. So this is going to be equal to sine alpha cosine beta minus or plus sine beta cosine alpha. And it's going to be all over, I'm going to write the denominator in a different color, cosine alpha cosine beta minus sine alpha sine beta. Now basically what we can do is we can multiply both sides, or both the numerator and denominator, by 1 over cosine alpha cosine beta. And this is just the same as dividing both the numerator and denominator by cosine alpha cosine beta. Now, because we're basically multiplying by 1, the value doesn't change. So we still know that whatever we get is going to be equivalent to what we got earlier. And this is going to be equal to sine alpha cosine beta plus sine beta cosine alpha all over cosine alpha cosine beta. Now that's just the numerator, and the denominator is going to be cosine alpha cosine beta minus sine alpha sine beta all over cosine alpha cosine beta. And basically, what we're going to do is I'm going to move to the other side, running out of space. We're going to basically split the numerator into 2 parts, as well as split the denominator into 2 parts. We're going to get that sine alpha cosine beta over cosine alpha cosine beta plus, I forgot the equal sign, plus sine beta cosine alpha over cosine alpha cosine beta. And that's just the numerator, and the denominator is going to be cosine alpha cosine beta over cosine alpha cosine beta minus sine alpha sine beta over cosine alpha cosine beta. So now let's start simplifying. So first, you can see how there's probably a cosine beta in this term, right? There's a cosine beta in both the numerator and denominator of this term, so we can just cancel that out. And we're also going to cancel out the cosine alphas in this term. And notice that this term in the denominator is just going to be equal to 1, because it's cosine alpha cosine beta over cosine alpha cosine beta. And basically what we're left with is just this: sine alpha over cosine alpha plus sine beta over cosine beta all over 1 minus sine alpha sine beta all over cosine alpha cosine beta. So if you notice, this is the sine of theta over cosine of theta, but just with alpha and beta instead. So we can actually just rewrite all of these terms as tangent alpha plus tangent beta all over 1 minus, well, looks like I forgot the alpha over here, tangent alpha tangent beta. Oh, and let me change the color. So the denominator is going to be 1 minus tangent alpha tangent beta. And basically, this is the tangent sum formula. Now we can do a similar thing for the difference formulas, and we can pretty much just plug in we can just switch the signs pretty much, and we're also gonna get that. So we're gonna get that tangent alpha minus beta is gonna be equal to tangent alpha minus tangent beta all over 1 plus tangent alpha tangent beta. So one important thing to note is that cosine alpha, cosine beta sometimes might be equal to 0. I'm going to write a note here. Note. So cosine alpha, cosine beta might be equal to 0 sometimes. So just be careful when using this formula. But anyways, that's pretty much all there is for the tangent sum and difference formulas. If this video has given you value, or if you like this concise, no BS way of teaching, then please consider supporting the channel. Otherwise, thank you for your attention and good luck in your studies.